Hello friends, today we will practice some integration, some more integration, so we can improve our integration skills. So first integral is we have to find the integral of cosecant x dx. To find it, we multiply and divide it by cosecant x minus cot x. So and then when we solve this, it becomes cosecant square x minus cosecant x cot x dx divided by cosecant x minus cot x. Now we can see here, we can assume that cosecant x minus cot x is equal to t. Let us put the value, let us put t in place of cosecant x minus cot x, and if we take the differential of cosecant x minus cot x, it becomes minus cosecant x cot x plus cosecant square x equals to dt, as you can see here. Now putting these values in this expression, what we get is integral of dt by t, which is simply this simple integral can be evaluated very simply. It is simply log of t plus c. Now putting the value of t here, we get cosecant x minus log of cosecant x minus cot x plus c. So this is the first solution. Now we get to find another integral. It's very basic, it's very simple. Integral of secant square x dx divided secant square x dx. Now what we do here, we know that from derivatives that d over dx tan x is secant square x. So there exists a function whose derivatives is directly secant square x. So we just we know that function is tan x. So the solution of this integral is tan x plus c. Now this one is a little bit tricky. So it involves some tricky maths. So what we have to do here is we have to find the integral of 1 over ax a square plus x square dx under the root. Now we will put x is equal to a tan theta, and if I take the differential on both sides, it becomes dx is equal to a secant square theta d theta. Now integral of now I will put the value of x as a tan theta and dx is equal to a secant square theta d theta. So in the numerator it goes a secant square theta d theta, and in the denominator it is under the root a square plus a square tan square theta. Now this a square is common here and here, so it can be taken out as I have done here, and this square will cancel this square root out, and this 1 plus tan square theta will be left as it is. Now moving to the next page. Now the square root, this a came from the square root, and we can cancel this a out with this a out, and 1 plus tan square theta became secant square theta, and this square cancelled this square root out, and it left us with secant square theta divided by secant theta. Now this secant theta will be cancelled by this square, and we are left with integral of secant theta d theta, which is equal to log of secant theta plus tan theta plus c. Now we had initially assumed that x is equal to a tan theta. Okay, we had initially assumed that x is equal to a tan theta. Now and then x over a becomes tan theta. Okay, and since 1 plus tan square theta is equal to secant square theta, then we can also get this value secant theta from this, which is a square plus x square divided by a. I've solved it on the side. You can do it yourself easily. Just follow along the steps. अच्छा, अब मैंने यहाँ पे जो है ना इनकी वैल्यूज secant थीटा और tan थीटा की जो मैंने साइड में कैलकुलेट की हैं, तो मैंने इस मास्टर एक्सप्रेशन में जो है ना पुट की secant थीटा की वैल्यू मैंने ये कैलकुलेट की थी. तो वैल्यू ऑफ secant थीटा इज इक्वल टू अंडर द रूट a स्क्वायर प्लस x स्क्वायर डिवाइड बाय a. So I put this value here, and the value of tan theta is x over a plus c. So log of x plus under the root a square plus x square divided by a plus c, and further I will simplify it, x plus a square plus x square under the root minus log of a, because we know the property of logarithms that if there is division in log, they can be separated into they can be separated out in two different logs, like here. So finally we know that log of a is constant, so it will change this constant to a new constant c1. So the final solution is log of x plus under the root a square plus x square. Okay, so that's the solution of that integral. Now we will solve another integral here, integral of dx divided by 7 minus 6x minus x square. Now what we do here, we convert into a square minus x square form. We will convert this into a square minus x square form. So that's what we do here. So integral of dx divided by minus x square minus 6x plus 7 minus x square plus 2 times x plus x times 3, and it further becomes dx divided by 7 minus x square plus 6x plus 9 minus 9, because just follow along the steps. It is very much self-explanatory. So integral of dx plus 7 plus 9, that minus 9, when it came out from the bracket, it got this minus sign became plus. So that's the plus 9 minus x plus 3 whole squared. So it becomes 16 minus x plus 3 whole squared. Now that becomes 4 square minus x plus 3 whole squared. Now we will let x plus 3 is equal to 4 sine theta, and dx will become 4 cos theta d theta. So we can also write sine theta as x plus 3 by 4 and cos theta as under the root 1 minus x plus 3 by 4 whole square. These values will be used later. Okay, now what we do here, we put the values of x plus 3 and dx in this expression. So it becomes 4 cos theta d theta divided by 4 square minus 4 sine square theta. So this 4 square will be taken common, and it becomes 1 minus sine square theta. This square will cancel this 4 out, leaving us with integral of cos theta d theta divided by 4 cos square theta, because 1 plus 1 minus sine square theta is equal to cos square theta. Now this cos square theta will cancel out this cos theta. It will leave us with 1 by 4 secant theta, because 1 by cos theta is equal to secant theta, and it further becomes 1 over 4 secant theta plus tan theta plus c. Now we can find the value of secant theta and tan theta using these functions that we have already defined. So the value of we know that secant theta is 1 over cos theta, so it's simply 2 over under the root 7 minus x square minus 6 is basically secant theta, and tan theta is simply sine theta over cos theta. So this is the value of sine theta, x plus 3 divided by 4, and cos theta is under the root 7 minus x square minus 6x divided by 2. So solving it further, we will get 1 by 4 log of 2 divided by under the root 7 minus x minus 6 7 minus x square minus 6x plus 3 plus x divided by 2 under the root 7 minus x square minus 6x plus c. So that's the solution of this integral.